Do wormholes really exist like we think they do? And what are they really like if so? Stay connected till end and we will together explore what wormholes are and how they works. So if you've watched any kind of sci-fi movies that dealt with space travel and such, you more than likely have heard of the concept of wormholes. To put it in the most basic of terms, wormholes are shortcuts in the universe. You go in through one side of the universe, and you come out in an area that is really far away from where you were just a few minutes ago. We have seen space travel trough wormhole already in Interstellar movie. But are these things really possible in our own universe? And if they were, wouldn't we have found one yet? The answers may surprise you. Einstein's theory of general relativity mathematically predicts the existence of wormholes, but none have been discovered to date. A negative mass wormhole might be spotted by the way its gravity affects light that passes by. Certain solutions of general relativity allow for the existence of wormholes where the mouth of each is a black hole. However, a naturally occurring black hole, formed by the collapse of a dying star, does not by itself create a wormhole. Wormholes were first theorized in 1916. Though that wasn't what they were called at the time. While reviewing another physicist's solution to the equations in Albert Einstein's theory of general relativity, Austrian physicist Ludwig Flamm realized another solution was possible. He described a white hole, a theoretical time reversal of a black hole. Entrances to both black and white holes could be connected by a space-time conduit. In 1935, Einstein and physicist Nathan Rosen used the theory of general relativity to elaborate on the idea, proposing the existence of bridges through space-time. These bridges connect two different points in space-time, theoretically creating a shortcut that could reduce travel time and distance. The shortcuts came to be called Einstein-Rosen bridges, or wormholes. Einstein and others have noted that there are potentially 5 different kinds of wormholes. Here are some basic explanations of each. Traversable wormholes. These wormholes are the most famous, especially in science fiction movies. Holes through which they cross at a point in the universe to get out of somewhere else. Most of you have watched TV program Power Ranger Dino Thunder in your childhood. In that program's villains uses wormhole for traveling from their hideout to city where they had planned to launch an attack. 9. Wormhole. Non-traversable wormholes. Nothing can cross. Either because these wormholes fall apart, may contain an inlet point without an outlet, or to sabotage the particles before they reach the other end. One-way wormholes. You can travel through one wormhole and need another wormhole to return. In one of the solutions of Einstein's equation, it turns out that wormholes can be found in black holes but are not crossable. White holes have a role in wormholes. They are the opposite of black holes where they ejaculate matter with enormous force. Two-way wormholes. This type of wormholes is the same way back and forth. Intra-universe. These holes are located in our universe and they allow us to travel from one point within our universe to another point. Inter-universe. These wormholes connect our universe to another parallel universe. You can see DC Comics or Marvel for these very unique kind of crisis wormholes. So right, there are many different kinds of wormholes and the impact that they could have on the universe and the people living within the universe at large. Which leads us to the big question: where are the wormholes in our universe right now? Well, we've already talked about that a little, in that there are a lot of theoretical wormholes in the universe via black holes, white holes, and other massive galactic entities, but they're only theoretical at present. To be clear, that doesn't mean that they don't exist, but it's another case of, it could be real, and it could not. This is the type of thinking behind another cosmic theory and mystery known as dark matter and dark energy. But that's another topic entirely. As Einstein theorized, the wormholes are breaches within the fabric of space-time, but it's possible that nothing in the universe has been able to breach that fabric. That's not saying it can't be done, just that it hasn't. Ironically enough, there are some sci-fi TV shows and movies that talk about ships creating their own wormholes through space-time by breaching this fabric. So maybe the reason we haven't found a wormhole yet is because we need to make one ourselves. Or, it could be that the wormholes are out. They're in space right now, and we just haven't found them yet. But how could we not notice a wormhole in space? The answer of this question is little complicated. Science fiction is filled with tales of traveling through wormholes. But the reality of such travel is more complicated, and not just because we've yet to spot one. The first problem is size. Primordial wormholes are predicted to exist on microscopic levels, about 10 to 33 centimeters. However, as the universe expands, it is possible that some may have been stretched to larger sizes. Another problem comes from stability. The predicted Einstein-Rosen wormholes would be useless for travel because they collapse quickly. You would need some very exotic type of matter in order to stabilize a wormhole, said Sue, and it's not clear whether such matter exists in the universe. But more recent research found that a wormhole containing exotic matter could stay open and unchanging for longer periods of time. Exotic matter. So what is exotic matter? It contains negative energy density and a large negative pressure. Such matter has only been seen in the behavior of certain vacuum states as part of quantum field theory. If a wormhole contains sufficient exotic matter, whether naturally occurring or artificially added, it could theoretically be used as a method of sending information or travelers through space. So if they are out there, when were they made? The most probable answer is the Big Bang, which is the theoretical event that scientists speculate was the birth of our universe. A moment in which an explosion of mass shot in all directions and created the building blocks of the universe via gases, matter, and more. It took millions and billions of years to form what we have now according to the theory. But that leaves a lot of times for certain holes in the universe to be formed. In fact, some speculate that because of the violent nature of the Big Bang that there are actually a plethora of wormholes in the universe right now, all connected to another wormhole via cosmic strings, and they are just waiting to be found. Plus, you need to consider this from the cosmic scope of things. Let's say that in a universe, the whole universe, there are 5 wormholes. Ones that have a way in and a way out. If you were to randomly place those wormholes in the universe, what is the likelihood of them landing by us? Or in a place that we can view? Would we even recognize them? Could we even see them in the darkness of space? Before we answer that question, be sure to like the video and subscribe to the channel. That way you don't miss any of our weekly videos. If you think about Star Trek, their wormhole was only seen after someone approached it. And a stable wormhole was rare, such as in Star Trek: The Next Generation, where one collapsed after it being entered by a ship, leaving them stranded light years away, which was why the one by Deep Space Nine was so special. And so, considering all of that, maybe the reason that we haven't found a wormhole yet is because we don't know where it is, and thus haven't viewed it yet. Thank you so much for watching our video completely till here. Stay connected with Quantumphile family for more such interesting video, and don't forget to like, subscribe and share this video. Right now we are in growing phase, so every subscription and like will motivate us a lot to make more such a video. Thank you, have a great day. Stay safe and enjoy a life. See ya next time.